Mic off. Poonam, mic off. Poonam ko mic off.
Hello, good afternoon to all, and welcome to you all to day 13, that is 11th August 2020, online class of grade 12 of the Celebration Co-ed College. I am Aishma Thapalia, the panel moderator of today's this classroom, and this classroom of today's is actually running by the students, and we'd like to thank our teacher, Mr. Sagar Dahal sir, for this opportunity because it is actually enhancing our core skills and also leadership as well. And today we are going to, me as well as my four other friends are going to present on the basic mathematics chapter 21, that is the Newton's law of motion. And for that, I'd like to welcome the very first presenter, Miss Kritika Gautam. Kritika, are you ready?
Yes, thank you, Aisma. Good afternoon, everyone. I'm Kritika Gautam from the Celebration Co-ed College from grade 12, and I'm here to explain about Newton's law of motion. Introduction. Sir Isaac Newton introduced the three laws of motion in 1687. While formulating the three laws of motion, Newton simplified massive bodies to mathematical points with no size or rotation. This allowed him to ignore facts such as friction, temperature, air resistance, material properties, etc. This helped him concentrate on phenomena that were described in terms of mass, length, and time. Consequently, the three laws cannot be used to describe precisely the behavior of large, rigid, or deformable objects. However, in many cases, they provide suitably accurate approximations. Newton's law pertained to motion of massive bodies in an internal reference frame, sometimes called as Newtonian reference frame. Although Newton himself never described such a reference frame, an inertial reference frame can be described as a three-dimensional coordinate system that is either stationary or in uniform linear motion. That it is not accelerating or rotating, he found that motion within such an inertial reference frame could be described by three simple laws. Next. Newton's first law. Newton's first law. The first law of motion simply means that things cannot start, stop, or change direction all by themselves. It requires some external force from the outside to cause such a change. The property of massive body to resist change in their state of motion is called inertia. Newton's first law is also known as the law of inertia. Newton's first law states that a body at rest or uniform motion will continue to be at a rest or uniform motion until or unless a net external force acts on it. Suppose a block is kept on a floor, it will remain at a rest until we apply some external force to it. Also, we know that it takes us more effort or force to move a heavy mass. This is directly related to the property known as the inertia. Hence, the first law of motion is also known as law of inertia. First law of Newton's first law चाहिँ के भन्छ भनेदेखि त्यो कुनै अब्जेक्ट एउटा रेस्टमा छ भने युनिफर्म मोसनमा छ भने त्यसलाई एक्सटर्नल फोर्स अप्लाई नगरिकन त्यो कतै पनि चल्ने छैन. We need to apply, however we have to apply some external force to change its place from rest to motion. Next. Inertia. Inertia is the resistance of any physical object to any change in its velocity. That is, an object at rest shows no tendency to move by itself, and similarly an object already in a motion continues to move in a straight line. The first tendency of an object is inertia of rest, while the second tendency of an object is inertia in a motion. त्यही फर्स्ट लको टेन्डेन्सीहरु चाहिँ फर्स्ट टेन्डेन्सीलाई चाहिँ रेस्टको रूपमा लिन्छ भने सेकेन्ड टेन्डेन्सीलाई चाहिँ मोसनको रूपमा लिन्छ. Here are some properties of inertia. Common experience of falling backwards when a car in which we are standing loosely suddenly starts exhibits the property of inertia of rest of a body at rest. First मा चाहिँ when we stay in a car हैन, कार भित्र बस्दाखेरि जब त्यो कार स्टार्ट हुनुभन्दा अगाडि हामी फ्री भएर बस्छौं हैन, जब त्यो कार चल्न थाल्छ नि, जब मुभ हुन थाल्छ नि, हाम्रो बडी आफै त्यो अररो भएर आउँछ कि, जसले गर्दाखेरि त्यो चाहिँ त्यसलाई नै त्यही प्रपर्टीलाई चाहिँ इनर्शिया property of inertia of rest भनिन्छ. The property of inertia of motion is exhibited by our experience of being thrown forward when we are light without precaution from a moving bus. अब जब हामी बसमा when we are staying in a bus or somewhere in car हैन, त्यो जब त्यो ब्रेक लाग्छ नि, ब्रेक लाग्दाखेरि चाहिँ त्यो हामी जब त्यो हाम्रो फ्रीली भएको बडी चाहिँ त्यो धक्का लाग्छ हो, त्यसलाई नै property of inertia of motion पनि भनिन्छ. Our definition of force. Newton's law defines what a force is. The first law serves the purpose of defining what an inertial reference frame is. The property of inertia of a body has no tendency of its own to change its state of rest or motion. It is not acted upon by some external force. It will remain either at a rest or in a uniform motion. That is, its original or natural states remain undisturbed or unbroken. A force is always necessary to cause any change in the state or uniform motion of a body. Force may be defined as force is that which on an acting body changes or tends to change the state of rest or motion of the body. The fact of inertial property of a body lies at the foundation of physical science, gave rise to the new name principle of inertia, to the Newton's first law of motion. Now, mass and momentum. The definition of force tells us that a force acting on a given body affects in property of inertia, which give rise to mass denoted by m, small m. To measure how much force acting on a given body changes its amount of inertia contains, we may assign to a numerical quantity that is called mass. Suppose the force acts on two bodies of a mass m1 and m2. The acceleration of the two bodies are also different. Experiments on the various types shows that a body of smaller mass acquires a greater acceleration as compared with a body of larger mass. If acceleration 1 and acceleration 2 are the acceleration of two bodies of masses m1 and m2 under the action of the same force, the ratio A2 upon A1 may be used to compare the two masses. For definition, the convention used is to say that the larger masses m1 is A2 upon A1 times the mass m2, and write m1 is equals to A2 upon A1 into m2. The above equation may be used to measure the mass of a given body by comparison with a standard unit of mass, that is kilogram. Given two bodies with mass m1 and m2, the mass of the composite body formed by fastening them together can be measured as described in above. It is actually found to be m1 plus m2 at all times. Thus, mass is found to be additive and is directly related to the quantity of matter. This explains the use of terms mass by Newton to mean quantity of matter. Now, talking about the momentum, the given force acting on two bodies with the different masses build up a higher velocity on a lighter body that on the heavy one. Secondly, a force applied on a greater mass is greater than a force on a smaller mass to acquire the same velocity after traveling the same distance from rest. Talking secondly, we can say that heavier body has a greater quantity of motion or momentum than the lighter one. Newton's for the first time defined momentum is the momentum of a body is defined as the product of its mass and a velocity. If m is the mass of a body and v is the velocity, then momentum is equals to mass into velocity. The SI unit of momentum is kg meter per second square. Thank you so much for watching and listening.
Thank you so much, Kritika, for your wonderful presentation. It was actually very much appreciable presentation, very good, very nicely explained everything about Newton's first law of motion. Newton's first law of motion ले चाहिँ के भन्छ हैन, if कुनै पनि body rest मा or movement मा छ भने it will be in the same state हैन, अनि until तबसम्म चाहिँ जब चाहिँ उसलाई एक्सटर्नल एजेन्सी अथवा एक्सटर्नल फोर्स चाहिँ उसमाथि एप्लाई हुँदैन, ऊ चाहिँ त्यही स्टेटमा बस्छ. Very nicely explained. Also, she has kept that this law embodies or it contains the very important two things that are properties of inertia and force. And thank you so much for actually describing about the inertia, the types of inertia, inertia of rest, inertia of motion, in a really nice and in fluent way. Also about the force as well. अनि उहाँले चाहिँ अझै मेन भन्ने पर्दाखेरि चाहिँ एकदमै नाइसली डिस्क्राइब अबाउट द डेरिभेसन्स, अल्सो द भेरी इम्पोर्टेन्ट फर्मुलाज जस्तै मोमेन्टम इज इक्वल्स टु मास इन्टु भेलोसिटी, अनि एसआई युनिट अफ मोमेन्टम, यस्ता साना साना कुराहरूले चाहिँ हाम्रो मार्क्स काटिन्छन्, जुन चाहिँ उहाँले चाहिँ हाइलाइटमा लिएर आएर एकदमै राम्ररी प्रेजेन्ट गर्नुभयो, हामीलाई बुझाउनु भयो. द्याट इज भेरी नाइस. Overall, our presentation was really helpful and it was very much good. Thank you so much, Kritika, Gautam. And now moving further, I'd like to call Miss Pratima Gurung for her another presentation on the part of Newton's second law of motion and mass and weight. Pratima, are you there? Please turn on your mic. Yes, you may proceed.
Thank you, Asma. Hello and good afternoon to everyone. It's me, Pratima Gurung from Celebration Grade College.
Pratima, will you click on your presentation slide? And you can hide that. Okay, that's good. From the beginning, please. Yeah, you can do F5. Click F5.
Sorry, it's not being.
Okay, no, otherwise near 68% there is one bucket one. Click that. 68% you can see there, and there is one bucket type. You can click on bucket type. Near 68% bottom, your time. Can you see the icon? Yeah, yes, click, yes, yeah, very good. Okay, please go ahead.
Today I'm going to present my presentation about Newton's second law of motion, and welcome to my presentation. Today's topic is Newton's second law of motion, weight and mass. I'm going to present it. Firstly, Newton's second law of motion, its definition. It states that the rate of change of momentum is proportional to the impressed force and takes place in the direction in which the force acts. Examples. Its example is, if you think acceleration as movement, then the greater the mass of the object, the more force needed to make it accelerate. Can be read as, the greater the mass of the object, the more force is needed to make it move. Objects with a greater mass have more inertia. It takes more force to change their motion. A 400 kg rock is a lot harder to move than a 40 kg rock. Now, let us see how this law provides us a method of measuring force. Firstly, suppose a force F acts on a body of mass m for time t and changes its velocity from u to v. The change in momentum of the body in time t is obviously mb minus mu. and therefore the rate of the change momentum is mb minus mu upon t. Then by Newton's second law of motion, F is inversely proportional to mb minus mu upon t. Or let us take m common and m common and v minus you get separated. Then we can write F is inversely proportional to m bracket v minus u close bracket upon t. But we know that v minus u upon t is equal to change in velocity upon time is equal to acceleration. Let us say a. Therefore, f is inversely proportional to ma, or f is equal to k into ma, where k is a constant. This is the equation which enables us to define an absolute unit of force. If we take m is equal to 1 kg and a is equal to 1 meter per second square is equal to 1 meter per second minus square, the numerical value of f becomes 1. If we take k is equal to 1, it is with this fact in mind we define the unit of force as that force which acts on a body of unit mass produces a unit acceleration. When we then have k is equal to 1 and therefore f is equal to ma. The SI unit of force is the force which produces an acceleration of 1 meter per second square, or 1 meter per second, must be minus square, sorry for that, when it acts on a mass of 1 kg. This unit of force is called the Newton. Thus, when m is kilograms and a in meters per second, f is in newtons, and then f is equal to ma. Or force is equal to mass into acceleration. The serious unit of force is dyne, which is a force acting on a mass gram, 1 gram, that is, produces an acceleration of 1 centimeter per second square. Magnitude of the force may be defined as the number of units in the given force. The force is completely known if its point of application, that is, the point at which the force acts, magnitude and direction are known. Weight and mass. For weight and mass, we have to first understand about gravity, because weight and mass depends are related with gravity. The large or small objects which are pulled or attracted by the earth is called gravitational attraction or force due to gravity. The space around the earth where the mass of an object experiences a gravitational pull or force due to gravity is called the gravitational field of the earth. Now, the definition of weight. The weight of an object is defined as the force acting on it due to gravitational pull or gravity. As I told, it is related to gravity, so I have written the definition of gravity, acceleration due to gravity also. And if the body falls freely in the absence of resistance of air, regardless their masses, and falls freely with the same acceleration at the same point near the surface of the earth, the body is called free falling body. The motion itself is given name free fall. The acceleration of a body falling freely under the action of gravity is called the acceleration due to gravity. Its value is taken to be 9.8 meter per second minus meter per second is minus square, or 980 uh, centimeter per second approximately. It depends upon latitude and elevation. For a body of mass m falling freely under the action of gravity, the force acting on it or its weight W is given by W is equal to mg, where J is the acceleration due to gravity. Since acceleration due to gravity varies from place to place on the surface of the earth, the weight of a body having a certain quantity of mass differs from place to place. In other words, we can say mass of a body is constant all over the earth, but the weight is not. Thank you so much. If any queries, you can ask me.
Thank you so much, Pratima. It was really nice presenting by you, and really nice, very nicely defined Newton's second law of motion, which states that the acceleration produced on a body is directly proportional to the applied force and inversely proportional to mass. Thank you very much. She has actually very nicely elaborated the derivation, the formula F is equals to ma, and also about the weight and mass. And majorly, she has also described the very little things as well, like the CGS unit, and also the very nice example of a man. They're pushing the mass of 400 kg with more force, and again in the next picture, pushing the mass of 40 kg in a very less force. That is very nice of you. Actually, very nicely defined about the weight and mass as well, which we have been learning from our very junior class. And this is very familiar topic for us. And thank you so much, Pratima, for your presentation. Now, I'd like to welcome Mr. Sandesh Pokhrel for his presentation on Newton's third law of motion, describing its definition, examples, and conservation of momentum and formula. Are you there, Sandesh?
Yes.
Yes.
Good afternoon, everyone. It's me, Sandesh Pokhrel from Celebration Co-ed College. Now I'm here to explain you about 1 minute. I'm here to explain you about Newton's law of motion. Newton's third law of motion. It states that when one body exerts a force on the another body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. Or in another way, in another words, in every action there is equal and opposite reaction. Example of Newton's third law of motion. First, when a bullet is fired from a rifle with a certain force action, the force is pushed back by an equal and opposite force. Second, the weight of the body is acting on the table in the downward direction. This is the action. The reaction is the table acts on the book in the downward direction. Third, if a heavy block is suspended by a string, the string exerts a force on the block to hold it, and the block exerts an equal and opposite force, making it tight and inextensible. Now, another one is conservation of linear momentum. The law of conservation of linear momentum states that if no external force acts on the system of two colliding objects, then the vector sum of the linear momentum of each body remains constant and is not affected by their mutual interaction. And now linear momentum of system of particle. We know that the linear momentum of the particle is p is equals to mb. Newton's second law for a single particle is given by F is equals to dp upon dt, where F is the force of the particle. For n number of particle, total linear momentum is p is equals to p1 plus p2 plus p3 plus pn. Each of momentum is written as m1 b1 plus m2 b2 plus mn bn. We know that velocity of the center of mass is v is equals to summation mi bi upon m, and as a result mb is equals to summation mi into bi. So comparing this equation, we get p is equals to mb. Therefore, we can say that the total linear momentum of a system of particle is equal to the product of the total mass of the system and the velocity of its center of mass. Differentiating the above equation, we get dp upon dt is equals to m times dv upon dt, as a result ma. dp upon dt is acceleration of center of mass. M times a is the force external, so dp upon dt is equals to force external. This above equation is nothing but Newton's second law to a system of particle. If the total external force acting on the system is 0, F external is equals to 0, then dp upon dt is equals to 0. This means that p is equals to constant. So whenever the total force acting on the system of a particle is equal to 0, then the total linear momentum of the system is constant or conserved. This is nothing but the law of conservation of total linear momentum of a particle. This is nothing but the law of conservation of total linear momentum of a system of particle. Thank you.
Thank you so much, Sandesh. A very nice presentation by you. Actually, very nice theme as well. And thank you so much. And he has actually elaborated a very nice topic for us, which has been my favorite from the very junior class, and that is Newton's third law of motion. To every action, there is equal and opposite reaction. And this is actually one of the very much essential topic for grade 12 as well in the NEB board examinations. And very nice examples like the bullet fired from the rifle, book placed on the table, and also the heavy block suspended by a string. Thank you so much, Master Sandesh, and very nicely explained about the elaboration of derivations and formulas. Hope everyone enjoyed it and everyone understood it. Thank you so much. Now, moving forward, I'd like to welcome Master Abin Tamang for his presentation on collision and also about the Newton's law of motion. Please proceed.
Good afternoon, everyone. My name is Avin Tamang, and today I'm here to explain about Chapter 21, Newton's Law of Motion. And the topics that I will be explaining are conservation of linear momentum and collision, elastic and inelastic included. So our first will be talking about conservation of linear momentum. About this, first, a body at rest has no momentum. If the body starts moving with a given velocity, it will have momentum whose direction is same as that of its velocity. So it has both magnitude and direction. It is therefore a vector quantity because it has both magnitude and direction. Moreover, it is a linear in nature. If the body has a mass m and changes its velocity from u to v in a time t, and in the direction of a force F acting on it, Newton's second law of motion tells F is equals to mv minus mu by t. In case F is equals to 0, we have 0 equals to mv minus mu. Therefore, if you bring mu to the other side, we get mu is equals to mv. In other words, whenever force is equal to 0, the body moves with constant linear momentum. Next. Instead of a single body, if you have two bodies of masses, m1 and m2 under mutual interaction but nothing else, each body exerts a force on the other. This brings a change in momentum of each of the two bodies. According to Newton's third law of motion, the forces on the two bodies are always equal and opposite in direction. If the velocity of the first body changes from u1 to v1 in the time t, the force associated with mass m1 is m1 times v1 minus u1 divided by t. Similarly, if the velocity of the second body changes from u2 to v2 during the same time t, the force associated with the mass m2 is m2 times v2 minus u2 by t. Now, hence, we get negative sign minus m1 v1 minus u1 divided by t minus m2 u2 v2 minus u2. This negative sign came because, as we can see here, they are acting against each other. This brings change in moment of each bodies, and according to Newton's third law, each and every action has equal and opposite reaction. So minus m1 v1 minus u1 is equals to m2 v2 minus u2 divided by t. So or minus m1 v1 plus m1 u1 equals to m2 v2 minus m2 vu2. Now if we arrange them, then we can get m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Thus, when two bodies interact with each other and no external force acts on the system, the total momentum of the system remains constant, both in magnitude and direction. The above statement is called the principle of conservation of linear momentum and is one of the most important principles of mechanics. The principle of conservation of linear momentum can be extended to the case of more than two bodies moving under similar conditions. As typical example, we may consider the motion of a shot and a gun. Suppose m and m are the mass, small m and capital M are the masses of the shot and the gun respectively. Also, assume that small v and capital V are the velocities with which the shot leaves the muzzle of the gun and recoil of the gun which is free to move. Then m times v minus 0 equals to m times v minus 0. Therefore, we can say that mv equals to mv. Now, that's the end of this topic. Now, let's begin collision. So consider two bodies moving on a same straight line on a smooth horizontal table. If they start from a point and move in opposite direction, they will not meet or join together. In the same way, if they move from different points with the same velocity and in the same direction, they will never come together. But if two bodies move from two different points towards each other, or one following the other has greater velocity than the latter, they will meet or come in contact or collide at some point, then two possibilities are obvious. They stick together, coalesce, and continue to move as a unit after collision with a common velocity, and they bounce off one from the other and continue to move separately. Next. It is to be noted that the collision may be between a moving body and fixed object also, that is, a ball falling on a ground. In the first case, we can say that the collision is perfectly inelastic, and in the second case, it is said to be elastic. That is because when they collide in first case, they stick together and do not bounce off and do not even change their shape and regain their shape. So, but in second case, they bounce off each other and they change their shape and again regain their shape. It's like that. In the case of perfectly elastic collision, In the case of perfectly elastic collision, the colliding bodies are first deformed as soon as they come in contact and then regain their original form. In particular, suppose two perfectly inelastic bodies of mass m1 and m2 are moving along the same line with the velocities v1 and v2 respectively, coalesces and moves together with a common velocity v. Then, by the principle of conservation of linear momentum, we have m1 v1 plus m2 vt equals to m1 plus m2 times v. Therefore, v equals to m1 v1 plus m2 v2 divided by m1 plus m2. Now that's it. Thank you.
Thank you so much, Arvin. Thank you for your presentation. Really nice presentation by you as well. And talking about, Arvin has discussed very much important topic, which is actually new for us as well. And that is the principle of conservation of momentum, which states that if two objects collide, then the total momentum before and after the collision will be the same if there is no external force acting on the colliding body. And he has also talked about the case of if F is equals to, if force is equals to 0, then mu is equals to mv. Thank you so much, Arvin, for that as well. And talking about the next topic you have spoke about, that is the collision. He has spoke the very important thing, that is the two possibilities inside the collision, and they stick together and continue to move as a unit after the collision with a common velocity. And another point was they bounce off one from the other and continue to move separately. Really nice presentation by you as well. Also, he has elaborated about the elastic collision and inelastic collision as well. Hope everyone actually enjoyed his presentations too, and it was really nice presentation by all four of you. And this chapter has actually become one of our now favorite, I guess, because for us, our friend explaining to us is more effective, I feel. And today's class has been actually more likely to be the same. So thank you so much, all the presentators. And also I like to thank Sagar sir once again for giving us the platform. And now I like to give the floor to Sagar sir.
Thank you so much, Aisma, Thapalia, and whole the four presenters, today's speakers. Am I audible?
Yes, sir, you are audible.
Okay, thank you very much. Thank you so much. This was the first experience at the Celebration College, and I'm very much happy with all the performers. And it is really, I have to say, WOW. It's wow presentation. So in coming days, now it will be also the lesson like sometime before Biswasar Acharya sir also has mentioned you in the chat box. So it is highly appreciable that now coming presenters will also think on it. So what you have to do regarding this thing is you have to be very much careful on the units. Whenever you speak, you have to be careful on the units, whether it is meter per second or meter per second square. And it's better not to say t to the power t minus 2 like that, because if it is in the negative powers, you have to say per. Okay, in that way you have to manage. And the more examples you have to explain. And whenever you like, I'm speaking with you and my eyes are under your observations. This is the way how we have to speak. And another thing is try to make your bullet points only 6 points. That means 6 lines. It is actually the standard format of the presentation is 6 by 6. That means altogether 36 words to 40 words it will be. But in a line, please arrange 6 words to 8 words maximum, okay, so that 6 bullet points need to be there in the presentation. In coming days you will add it. And another is what you have to do for upcoming presenters. They have to manage it, and they have to collect all these ideas. You have to collect the pictures and photographs, because visual perception is far better than the theoretical line by line mode of delivering. So pictures needed more in your presentation. Another is you have to bold the formulas, or you can make it box, or what you can do is you can change the color of important part, like I have seen in some presentation. So you have done your best. And another thing is you have to make a little bit interactive also, like you can ask, you can give there some multiple choice questions and what can be the options among them, so that all the participants attention will be towards your presentation. So actually I have to say very much thank you to all the speakers, and special thanks to Aisha Thapalia, as author has read 2 or 3 pages for preparing this presentation, but she has to read all these 8 to 9 pages. Being a moderator, you have a greater role. So thank you so much. And the platform given by the Celebration Kuwait College, we highly acknowledge this. Thank you so much, all the presenters. And now I would like to stop the recording.